3 algebra. We're continuing through CO5. Sawyer, what's your question?
Never mind.
Okay. So yesterday we talked about fraction and value equivalency, and that equivalent values, they have the same value even though their numbers might be a little bit different. We then started talking about fractions, and we did some equivalent fractions. We talked about how to tell their equivalent by decimal values. Not going to spend a ton of time on this, but just a few of them. 24 and 36. What is an equivalent fraction that someone came up with for 24 and 36? Melanie.
192 over 280.
Wow! 100. Oh, it's going to be one of those days. Is it, board? Okay, hold on. Technical difficulties. Let's see if we can figure out why it's not letting me write on the thing. Oh, that's not good. Well, I'm supposed to be writing green, not black. Oh, I can't. Oh boy. It's one. Okay, hold on. We're gonna pause the video because this is something that takes me a long time to figure out. Okay, here we go. Back in action. So, Melanie, please remind me what you said.
192 over 280.
280.
88.
Okay, 288. And what did you multiply by to get 192 over 288? 8, okay? You can multiply by anything as long as you multiply both the numerator and the denominator by the same thing. Now, did she really multiply the fraction by 8?
I didn't get that answer.
No, I mean, you could have done something else.
You
right?
can multiply by any
You can
number.
multiply by anything. Yep. Because here's the thing.
I thought it was 5.
That's just what we did yesterday on the first two. You can multiply by anything. Because really, did Melanie multiply the fraction by 8? No,
No.
she did not. Because multiplying something by 8, Sawyer, changes the value. Right? When you multiply something by 8, the value changes. If I have 8 times as many tater tots as you do, I have more. We do not have the same. Okay? So, really, what did Melanie multiply the fraction by? And this is the whole point of how equivalency works and why fraction values don't change.
Wait, I know.
1. Okay? 1. 8 over 8 is 1. She multiplied both the numerator and the denominator each by 8, but as a fraction, she multiplied by 8 over 8, which equals 1. And what we talked about, when you multiply by 1, the value doesn't change. Okay? Now, who did something else? Now what? Oh, there we go. Who did something else? Struggle bus today. What did you multiply or divide by?
5.
By 5, okay? So if you multiply by 5 over 5, what did you come up with?
The answer?
Yeah.
48 over 72.
So then you didn't multiply by 5, you multiplied by
Oh, wait, no, that's 2.
2. Yeah.
It was 120 over 100.
Okay. Hey, folks, a lot of conversation going on, and I'm not quite sure why. Because I'm up here teaching. Okay. They're in the cupboard. You can open up the left side, maybe the right side. One of those. Come on. Thank you. 120 over 180. Okay. Now again, did Madison multiply the fraction by 5? No. What did she multiply the fraction by? 1. She multiplied each number by 5, but not the whole fraction. If she multiplied the fraction by 5, the value would change. With equivalency, it doesn't. So she really just multiplied by 1, even though the numbers are different. Now, how can we prove, this was also yesterday, how can we prove that 24 36 and 120 over 180 are the same value? Ava?
Well, so you divide 24 by 36.
Yes.
You get a number, and then you divide 120 by 180, and you get the same number.
Right. If you divide 24 by 36, you get 0.6 repeating, right? 0.66666. It ends up being a 7 down at the end of your calculator. That's only because it.
I got 0.67.
Yeah, and if you round, then you get 0.67. But in your calculator, it should be 6 repeating. If you take 120 divided by 180, because remember, fraction means division, that also gets you 0.6 repeating. So we use decimals, thank you for cleaning up. We use decimals to prove that these fraction values are equivalent. Okay? Now, you may all have different answers for the rest of these, so we're not going to go over all of them. But are there any you're not sure about that you want to discuss? You want to talk about? Okay. Here's the nitty-gritty now. This is just the appetizer. Here's the entree. This is all leading up to proportions. And proportions are going to be a big part of pre-algebra. Does anyone know the definition of a proportion? A really big helping at lunch. No. A proportion is simply two equivalent fractions. That's why we spent the top part talking about equivalent fractions, right? Two equivalent fractions make a proportion. So, the one we just had, 24/36, we made a second fraction, 120 over 180. Those two fractions make a proportion. 24/36 is equal to, has the same value as 120 over 180. And we got there by multiplying by 5/5 or 1, okay, to get those new numbers. Good so far. Okay, here we go. This is the fun part here. We get to solve proportions, okay? And we're solving proportions using equivalent fractions to help us. I've got this here, 1/2 equals n over 60. First of all, how do you know that these two fractions are equivalent? How do you know that they make a proportion? There's something in this that tells you, yes, this is a proportion. Connor, stretching, or do you know?
Is it because 2 can go into 60?
Not because 2 can go into 60.
Because there's an equal.
There's an equal sign there. Okay, 2 can go into 60, which is awesome for us. It'll make this a lot easier, right? But the equal sign tells you that these two values make a proportion. So now going to what Connor said, the fact that 2 does go into 60 can help us solve for n. Because, Connor, how many times does 2 go into 60?
30?
30, right? So if we multiply 2 by 30 to get 60, what are we going to multiply the 1 by
30.
to solve for n? 30, right? Just like we did kind of in the top part there. If we have 1/2 and we multiply that by 30 over 30, we are going to get 30 over 60, right? Using that scale factor with equivalent fractions. So 1 times 30 equals 30, therefore n equals 30. Okay? Using equivalent fractions to solve for a variable. The next one, 12/15 equals n over 30. What's my scale factor to get from 15 over to 30?
2.
I have to double it, right? 2. So what do I have to do to my 12 to solve for n?
Multiply by 2.
I double it, okay? Same thing like we did on the front side, right? Or first page, whatever. We have 12/15, and we multiply that by 2 over 2. That's going to give us 24 over 30. So n equals 24. Okay? See if you can do the next one on your own here, right? This time we know both of the numerators, so we're going to start up top and we're going to say, how do I get from 3 to 27? How do I try on your own? How do I get from 3 to 27? And then do that same thing in the denominator to figure out what that n is. Okay? And if you're feeling super bold, brave, you believe in yourself, you can try the last one also.
Sorry.
So hopefully, above here, you've got a times 9, because 3 times 9 equals 27, which means down below, you've got times 9 as well. And so what does n equal? 90. N equals 90. Anybody not get that and not sure why? Next one's a little bit trickier perhaps, because it's using factors you might not be familiar with. But again, knowing both our numerators, we're going to start up top. What do we multiply 14 by? How do we get from 14 to 70, Madeline? Multiply by 5, which means, down on the bottom, we're doing the exact same thing. Because these are equivalent fractions. They make a proportion. So, 17 times 5 gives us, Ava?
85.
And n equals 85. Okay? You all deserve a button for that. You were all just on top of it today. Good. Questions on any of those? Okay. The bottom is a little bit different in the sense that, notice in these first 4, the n, the variable, is always in the second fraction. In the next 4, the n is always in the first fraction. Okay? Which means another method you could use is, instead of going from left to right like we did in the top part, we can go from right to left using division instead of multiplication. You can still use multiplication to solve these, and if you have been, like, you don't need to change anything. But another option, especially with your variable being in the first fraction, is going from right to left. So what would we divide 72 by to get to 12?
6.
What's that scale factor? The scale factor is still 6. Right? 72 divided by 6 equals 12. And so, in the numerator, going from right to left, what would we do to get from 24 to figure out what n is? Divide by 6. Exactly. Right? And 24 divided by 6 equals? 4. Now you could use multiplication for this also, right? You might look at this and say, okay, I know that 12 times 6 equals 72, so what times 6 equals 24? You get 4 that way also. Which is why I said if you started using the multiplying, don't change anything. You're not wrong, okay? This is just another way. Right? It's always good to have multiple tools in your toolbox, right? Multiple tools in the toolbox. So, the next one. Again, we'll practice the division method here. Going from right to left. 99 to 33. My board's like lagging today.
You divide by 3.
Divide by 3, exactly.
Oh yeah, Leo.
Okay? Then, 51 divided by 3. Do the same thing, going from right to left. Since we divided by 3 to get from 99 to 33, we're going to divide by 3 to get from 51 to n. 17. 51 divided by 3 is 17. Okay? Again, go ahead and try the next two on your own. You can use the multiplication method if you are just rolling with that. If you want to try division, because that works too. Going from right to left, how do we get from 44 to 11? And the same thing from 24 to n. And then 90 to 18. Apply that to the numerator as well.
I like this. This is fun.
Good. I'm glad you do, because we're going to do proportions a lot this year. So, yeah, questions? Yes.
Should we do these as well?
If you want to start on the word problems at the bottom, you can do those too. We'll talk about those together. Okie doke. From 44 to 11, what do we do? Divide by 4. Okay? Which means in the denominator, Sawyer, what do we do?
Huh?
If we got from 44 to 11 by dividing by 4, how do we get from 24 to n? divided by 4, the exact same thing. And what is 24 divided by 4?
6.
N equals 6. There it is. Okay, good. Last one, 90 to 18. What'd you divide by, Claire?
5.
Divide by 5, which means we have to divide up top by 5 as well. 65 divided by 5 equals 13. So N is 13. Okay? Questions on those 4? Anybody still jotting down answers, notes, work? We're good. Huh?
Is the bottom ones the same thing as one?
Pretty much, yeah. The bottom 3 are like, when would you actually care about a proportion? Yeah. Is there a question? Sure. So who are my bakers here? Who are my chefs, my recipe readers, my food fanatics? Okay. You probably have used proportions before, right? If you are making a recipe of blueberry muffins for your middle school teachers, just saying, right? And if your recipe makes 8 muffins, and for 8 muffins you need 75 blueberries, however, you want to make 40 muffins, would you still use 75 blueberries for 40 muffins? If the recipe says you need 75 for 8? No, right? Because if you're supposed to use 75 blueberries for 8 muffins, but you're making 40, but you don't change the number of berries used, there are not going to be very many berries in those. Okay? This is an average of like 10 berries per muffin. This would be like 2 berries a muffin. So this is where proportions work. It says it can be written as 75 blueberries for 8 muffins, but if I'm increasing that to make 40, what's my scale factor? How did I get from 8 to 40?
You have to multiply by 5.
Multiply by 5. So if I'm making 5 times as many muffins, I'd better use 5 times as many blueberries. Better go shopping. You're right, yeah. Okay? What is 75 times 5? Who's got the quick maths here? 375. So you need 375 berries if you want to make 40 muffins. If you're increasing, what's that?
Well, I thought it was too big of a number, but then I realized, oh, it's just like our end.
Exactly. Yes. Yep. Yeah. So if you're increasing that recipe by a scale factor of 5, you need to increase every ingredient. Otherwise, it's going to taste different. Right? These berries here, or these muffins here, would be delicious. 10 berries a muffin? Scrumptious. But if you made 40 muffins with still only 75 blueberries, they're not going to be very blueberry, right? They'll be too muffiny. Not that that wouldn't be good, but still. You decided to start saving $9 every 2 weeks in order to save up for a bottle of pure maple syrup shipped directly from Maine. If you have never had a bottle of pure maple syrup shipped directly from Maine, you have not lived yet. Okay, this is quality stuff. How many weeks will it take you to save $81? You probably can figure this out mentally without writing a proportion. Okay, but the math behind it, Liam, close your computer. The math behind it. Maureen, what are you doing on yours?
I'm doing a calculator.
Oh, well, bring a handheld one, because I can't see what you're doing on there. There are some kids who just play games on there. Not you, but others. Others like the way. But the math behind this comes down a proportion, right? If you are saving $9 every 2 weeks, you want to know you'll save $81 in how many weeks? What's the scale factor to get from 9 to 81? Let's get somebody who haven't heard from me yet today. You are rocking this. Awesome. Somebody haven't heard from me yet today. How do you get from 9 to 81? What's that scale factor? Times 9. So, Marina, what are you going to do in the denominator with your 2 weeks? Times it by 9. And how many weeks will it take you to save up $81 for this pure maple syrup, Liam?
18.
18 weeks. Proportions can be a tool, a very, very helpful tool to visualize what's going on. Because once you get it set up like this, you now have a method. Right? You've got a method to solve this here. Lastly, We've got a bottle of pop, it's $1.69. Yeah, now it's like what, $2.50, something like that? Back in when I first started drinking pop, it was 99 cents. And you know how you can like win prizes by scanning codes? Back in the day, if you won, they put it on the underside of the cap. So you could buy a bottle of Dew, you could twist off the cap and then say, free 20-ounce Dew. You're like, oh, I go get another one. It's great. The 90s were awesome. Anyway, a bottle of pop's $1.69. How much will buying 24 bottles cost? Okay. Again, you probably know what to do here without setting up a proportion, but the math behind it is a proportion. If one bottle is $1.69 and you want 24 bottles, you're multiplying 1 by 24, which means how many times are you going to pay this $1.69 price? 24 times. And what is $1.69 times 24?
$40.56.
Was it?
$40.56.
$40.56. Well worth it, I am sure, for a mouthful of sugar. Okay, no homework for tomorrow. There will be a homework check on CO5 with these questions. It will not be a bell ringer. It'll be a homework check. You will do the homework. If you need to redo the bell ringer, please do that. We have to end the video. That's my math.
Don't forget to like and subscribe.